using the framework. And this is a talk really designed to complement that. For people who already know a little bit of Rx and you're using it in your own code, I want to do a bit of a deeper dive into how observables work, what they really are under the hood, and how to think about solving problems with them. So this code example here really illustrates for me the main point here, that although promises and observables are both asynchronous primitives, they're fundamentally different, and we can't just take an API call getData that returns a promise and change promise to observable and expect everything to continue working in exactly the same way that it did before. You really have to think about the meaning behind these things and how these two APIs are different. And we're going to approach this subject in 3 different parts. First, we're going to take a deeper look at asynchronous primitives in general and how observables kind of fit into the family there. Then we'll talk about Rx operators and some of the more interesting ones that we can use. And finally, we'll end with a practical look at a few of the patterns and anti-patterns that I've seen in real large-scale applications, both inside and outside of Google. So let's get started. In the very beginning, right, we have callbacks. Callbacks have been in JavaScript since the beginning. They really got popular with Node.js, with single-threaded asynchronous server-side programming. They're a very simple and a very lightweight way of waiting for something that's happening asynchronously. So here we're using the Node HTTP API, http.get. We pass in a URL. We pass in this callback function that'll get called whenever the result is available. And we're just console logging it. And what I want you to notice about this code snippet is the part marked here in red, right? This is the extent of our HTTP call in the code. And what you notice is that the callback, right, the definition of what to do next, is actually contained within the call itself. And this is a fundamental feature or a problem with callbacks. You have to define what to do next when you're initiating the operation, when you're in the process of making it. And this leads to the problem that we all know as callback hell, right? When you have this long chain of asynchronous things that need to happen, you have to declare the whole thing up front, right? One thing nested inside the other. And every step contains the callbacks of all the steps that happen after it. And that becomes really messy and really limiting very quickly. And that's why promises were so awesome, right? Because a promise lets us abstract that concept of waiting away, right? It's a reference to a value that may or may not be available yet. And it lets us perform the operation. In this case, we're making the same HTTP call using the fetch API and not worry about declaring what happens next, right? In fact, we can do that in a different file. We can pass that promise around. And eventually, we can say, OK, promise, go ahead and run this callback whenever the result's available. So the fundamental improvement that promises made was this decoupling of the initialization of an action, right, the initiation of an operation, from what comes next. With promises, we can initiate operations and then worry about what happens. They abstract the idea of waiting, of expecting a future value, and they allow us to treat that expectation as a first-class object in our code. But they're not without their downsides, right? Promises only ever have one value in their entire life. That makes them really unsuitable for representing data that's changing over time. For example, a stream from a Firebase database, right? It's really hard to represent that with a promise. And they also go in one direction only. There's no way to actually cancel an in-progress operation if you only have a promise and are waiting for it to finish. And that's really where observables come in. Observables are like promises, and this is the only time in this talk you will hear me say that. Observables are like promises in the sense that they are also asynchronous primitives, and you can use them to solve the same problems. But those solutions are going to look different because observables under the hood are very different animals. So observables, as you probably have heard, they support multiple values, and you can cancel them. And those are useful distinctions. But the real thing that sets them apart is their laziness, right? A promise represents an action which has already begun, and we're waiting for it to complete. An observable, on the other hand, represents an operation that hasn't even started yet. So let's go ahead and define these two terms a little more rigorously. We're going to talk about computations, and computations can be performed eagerly or lazily. And if we state that a computation is eager, that means that it's evaluated as soon as it's defined, right? As soon as the JavaScript execution engine gets to a statement, and runs that line. If a computation is done lazily, it means that it's not evaluated until it's needed, until the result is actually required. And that's an important distinction between many imperative and functional programming languages. Right? If you've done any functional programming, you probably know that computations generally are lazy. They don't happen until you need the result. But we can actually mimic this in an imperative language like JavaScript. And we do it using functions. So the top line here, this computation of eager result, adds the numbers 1 and 2. And as soon as the JavaScript interpreter gets to this, it'll compute the result 3 and store it in a variable. But just by wrapping that computation inside a function, now when the JavaScript interpreter gets here, it stows those instructions away and it doesn't actually run them. It's only when we call the function that we actually make that computation. So with that simple definition in mind, we can start building our mental model of how observables and promises are fundamentally different. So we're going to consider two axes here. On the vertical, on the left-hand side, we have eager versus lazy. And along the top horizontal, we have synchronous and asynchronous. Right? So what's an example of a value which is both synchronous, available right away, and eager, right? Computed the moment it happens. Well, that's just any scalar value, a string, an object, a number, right? Anything that doesn't require us to compute it or wait for it. And we saw an example of synchronous and lazy, right? That's a function which returns a scalar. It's still synchronous. We call it, we have the result immediately. We don't have to wait. But it doesn't actually get computed until we call the function. So how about this asynchronous side? Well, it might surprise you a little bit, but promises are actually eager. When you have a promise, that means the operation that's computing the value is already in progress. Like when we call the fetch API, we get a promise back. The browser is already making that HTTP call, and it's going to return a result to us eventually. It's asynchronous, but eager. And that leaves us with one empty square, right? Any guesses? Not yet, right? You can actually have a function which returns a promise. That's both lazy, right? The promise doesn't get created. The operation doesn't start until you call the function. And it's asynchronous. We'll get our value back over time. And it turns out we do this all the time, right? This is exactly how a lot of services work. So we have this constant get data. It's a function that calls fetch. And whenever we call get data, an HTTP operation starts. We wait for our promise to resolve, and we get our data. And here's an important distinction, right? Every time we call this getData function, a new operation happens in the background because that computation is tied to the promise, and every time we call the function, we get a new promise. So this is a pattern that gets used over and over in services, right? We have API service, it's full of functions like getData. They return a promise to data. We do this all the time. So back to our model. Asynchronous and lazy is a function that returns a promise. Also in this box is the observable. And that is key, right? It's not a function that returns an observable. An observable is of itself an object that behaves like an asynchronous function. It represents an operation that could be performed and allows us to trigger that operation on demand whenever we want. And once we trigger that operation by subscribing, the values are returned asynchronously, just like a promise. So here's how we define such a thing, right? We're invoking the observable constructor. If you ever use the promise constructor, it's kind of similar. You pass it a function, and that function will get called every time someone subscribes to the observable. And inside that function, we get the subscriber, and we can do anything we like. Synchronous, asynchronous, doesn't matter. And when we want to push data to the subscriber, we call subscriber.next. So in this case, we're doing the same thing we did with our promise. We're wrapping the HTTP API. When we get our result callback, we push it to our subscriber. And the equivalent of calling the function then for an observable is subscribing. When we subscribe, we pass the callback that's going to get called whenever the observable emits. And if we subscribe a second time, it's like running the function a second time. We get another HTTP request made in the background. And unlike functions, we're not limited with unlike functions, we're not limited with an observable to returning just one result. We can emit as many times as we like. So here's an observable that just ticks away time every second using the setInterval API. And this example also illustrates another property of observables. They can actually understand when their subscriber is no longer interested in them. So from the function we pass in the constructor, we can return another function, and that gets called whenever the subscriber unsubscribes. There we can clear up or cancel any kind of long-running in-progress operations, HTTP calls. In this case, we're clearing up our timer. And that makes observables really powerful because they have back pressure. Right? They know when the UI is no longer interested in them. So getting back to our API service from the beginning, we've now learned that a promise and an observable have similar purposes, but they operate in very different ways. So it'd be rather strange to replace promise with observable in this getData function, because that's like declaring a function that returns something like a function that we would then call. Observables, remember, are by nature already very much like functions. So most likely, we'd want to expose this data observable directly. And it's safe to do that because unless someone subscribes to it, no calculation will actually happen. Right? This is a very cheap operation to create this thing. So now that we're armed with this mental model of observables, we can jump into operators. Operators are where the real power of Rx starts to show. So they are the observable equivalent of function composition, wrapping one function with another. An operator transforms an observable into another observable without subscribing to it. And the logic in the operator is also then lazy, right? It won't execute until the resulting observable is subscribed to. And Rx has over 100 of these things. I certainly don't know them off the top of my head. Some of them are pretty specialized. You only use them in very specific circumstances. I find most applications have about 20 different operators that they use on a regular basis. We're going to cover some of the more commonly used ones, particularly operators that focus on 3 use cases: transformation, projection, and combination. So the first set of operators I'm going to talk about are ones we're pretty much used to dealing with on arrays already. There are a few of them, but the most important two are map and filter. So map works identically to an array. It transforms one value to another using a projection function. Filter, on the other hand, uses a predicate to decide whether to include or exclude each individual value that's coming through. So here's how map works in code. We have this source observable, and we're going to initialize it with an array of numbers, 1, 2, and 3. So it'll emit the values 1, then 2, and then 3. And with the map operator, we're just going to transform each value by doubling it. And we get back this mapped observable. And when you subscribe to that, it gives us 2, 4, 6, right? Very straightforward. But this map operation doesn't actually do anything to the source observable. It doesn't transform it in any way. And we can still subscribe directly to it and get back our original sequence, 1, 2, and 3. Right? It's very functional. So the second set of operators that I want to talk about are the projection operators. And this is where it starts to really get interesting, because these transform a value into a whole stream of other values. And that transformation can even be asynchronous, which makes these very useful operators. They're kind of the bread and butter of using Rx. So one common operation, for example, might be to take a stream of IDs and make an HTTP request to get data for each ID. And a very naive way of doing this, you see a lot of people starting out with Rx think, oh, okay, I know map. I'll just use map and map this value into an HTTP call. The problem is that map doesn't actually understand that the value you're transforming it to is an observable. So you end up with this thing that's an observable of data, right? And you see that in your IDE and you think, oh God, what happened? But this is actually somewhat common in Rx. We call this a higher order observable. And if you think about it, it makes sense. We've turned each ID into an asynchronous function that if we call it, if we subscribe to it, will get us the data for that ID. So what we really want to do, though, is then flatten those results down. We want something that will actually subscribe to that observable that we've created inside our map function and give us the values that come out. And that sounds relatively straightforward, but it's actually a vague requirement, right? There are a lot of different ways we could do this. Do we subscribe to every HTTP call at once and return the results in whatever order they come back? Do we wait for the first one to finish before we do the second one? there's lots of different options there. And Rx has operators for each of these. So these are the projection operators. They all accomplish the same task of turning a higher order observable, right, an observable of observables, into a lower one, but each with a slightly different kind of behavior. Merge all, for example, will subscribe to all of them as they show up and combine all the results into a single stream without caring about what order they come back in. Concat all takes a slightly different approach. It subscribes to the first one, waits for it to finish, subscribes to the second one, etc. down the line. Switch all actually will unsubscribe from the previous observable that it's listening to whenever a new value shows up, right? So it's always going to subscribe to the latest one. And a little bit of trivia, for the longest time, I thought these were the three operators there are, but there's actually a fourth one in Rx. It's called exhaust, not exhaust all. And it's pretty exotic. I've only ever seen it used in one application. And what this does is ignore new values while the old subscription is still running. So it drops, it's kind of the opposite of switch all in that sense. So what does this look like in code? Well, starting from our source observable, we use map again, and we turn each ID into an observable that fetches the data for that ID. And then we call concat all. And that'll give us back a stream of data where each value is corresponds to the data for each ID. So we'll get the data for ID 1, then the data for ID 2, and the data for ID 3. And it turns out that this pattern is so prevalent in Rx, mapping to a higher order observable and concating or merging or switching back down, that Rx has shortcut operators for all of these. So we have the concat map operator, which does both steps at once, right? Transforms into an observable and flattens them back down again. But one mistake I see beginners in Rx use is they choose the same projection operator, and usually they pick merge map every time they want to do something asynchronous with an observable. And in fact, merge map is a pretty poor choice. I would argue that concat map should be your default asynchronous operator if you're going to use one of them. And why is that? Well, it's because most of the time when we work with source observables, they're in a particular order. We're processing events, click events from the DOM, form changes, etc. And we want to preserve that order even as we go through our asynchronous steps. And that's what concat map will do for us. It'll actually preserve that order as it subscribes to each inner observable. Switch map you should use when a new value makes everything you were doing before obsolete. The common example here is autocompleters. If you have an autocompleter and the user types the next character, you want to immediately stop with the query that you were doing previously and jump to subscribing to the new value. Form changes, right? Value events from forms, parameter observables from the router, also kind of similar. You really don't care if the user navigates to URL 1 and then 2. You want to get the data for 2. They've already left the page for 1. There's no need to hang around and fetch that. And merge map actually is not really needed that much in code. You really only use it when you're combining multiple streams of the similar type of data, and you don't really care what order they come in. And as I mentioned, exhaust map, nobody ever uses that one. So another issue with projection operators that I see is people needing to access both results, right? So this mapping operation, we make one HTTP request for /first, and then we make a second HTTP request that depends on the URL that came back in first. And if we were to subscribe to this, we would get a stream of the results of the second request. But what if we still wanted to access data from that first request, right? What if we wanted both of them? It turns out that all of these operators accept what's called a selector function, which can customize the output using both the inner value and the outer value. So for example, here we're using concat map to do the same thing. But we're now passing it this function that takes first and second and returns an object that composes them both. And this is really useful when you're writing these long asynchronous flows where you do something like start with the router parameters to get the current route ID, do a bunch of transformations on it, and at the very end, you want to post data back to the server using the same route ID, and it was all the way at the top, and you didn't really plummet through to the bottom. That gets really tricky to do normally, but with this pattern of passing the outer result through, it can be really easy. So the last set of operators that I want to cover are the combination operators. And these join together multiple input observables into a single stream. There are a few of them, but the two that I want to cover are combine latest and with latest from. So combine latest is a function, and it takes multiple observables as parameters. And the first thing it's going to do is it's going to wait for them to all emit once. And when they do that, it will emit, by default, an array with all of the values in it. And then as each observable emits, right, if any of them emit, it gives you a new array with the latest values that it's seen from all of them. So this is really useful when you want to do a database join, for example, where you're waiting on two different Firebase tables or two different Firebase queries, and you want to get the results from both of them at the same time. By default, it'll emit that array, but just like with concat_map, you can pass a selector function and customize exactly how you want the values to be combined. I find it's very useful to combine them into an object rather than receive them as an array, because then you're referencing, result dot, user and result dot account, and not, result bracket 0 bracket 1. And finally, the last operator we'll talk about is with latest from. This is a pretty cool little operator, and what it does is sideload another stream into the current operation that you're doing. So every time your main observable emits, it'll take the latest value it saw on your side observable and combine it, again using the selector function, with the main value. So here we're watching a Firebase database, but we don't actually care when the Firebase database changes so much. We just want to merge it with the form values that the user's piping in. So whenever the form value changes, we just go and get whatever's in Firebase at that moment, merge it together, and emit the result. And this brings us to the final section that I wanted to cover, which is best practices. We're going to look at a handful of patterns and anti-patterns that I've seen in real applications. So first up is a pretty big anti-pattern, nesting subscriptions. Just don't do this. Rx works best when you start with an event that's emitted from the DOM or from a WebSocket or a database or something, go through a sequence of operators that transform that event into an update to your UI, and then a subscription that happens as close to the UI as possible. And what that does is allow cancellation and that back pressure of unsubscription to work properly, right? If the UI decides it's no longer interested in a value, if it unsubscribes, all the work that's being done to produce that value should come to a stop. Instead, what you can do is use projection operators to handle all these asynchronous steps and only subscribe at the end. So let's look at what this looks like in the wild. Here we're doing that same thing where we're making two HTTP requests, the second one depending on the first. But this time, whoever wrote this has put the subscribe for the second request inside the subscribe for the first. And they're also saving the values out into the component context. And this is kind of hard to read. You're not really sure when these events happen. We've introduced the state now where this.first can be populated and this.second is still waiting. This messes with cancellation. So if I cancel this outer observable, the inner one doesn't know about it. It introduces side effects in the middle of computation. It's just not a great way to deal with Rx. We can definitely clean this up using the concat_map operator along with the selector function. And this is how you should write it. Now all the computation happens in the operators. It can be canceled by canceling the subscription. And we update our component UI in one fell swoop without these intermediate states where some things are loaded and others aren't. So let's look at a good pattern next. How to manage subscriptions. When components are destroyed, it's important that they clean up their subscriptions. Not only does that prevent memory leaks, but it also can prevent some really strange behavior when a component you thought was gone and off the screen, right, suddenly gets an event in one of its observables. Maybe it was still listening to NGRX, and then it does something and triggers an update in the application. Unsubscribing is not actually that hard. You don't have to manually track subscriptions. We're going to look at a pattern which uses an onDestroy observable and an operator in order to do this more or less automatically. So the way this works is you first have to turn Angular's onDestroy lifecycle event into an observable that you can listen to. And to do this, we use a subject. So we create this onDestroy observable as a subject. And in the ng onDestroy event, we just next at a random value, right? So now we have this observable that's going to emit whenever the component's destroyed. So next, whenever this component does any kind of subscription, the last operator in our chain, right? Here we're making an HTTP call. We go through map, switch map, whatever. The last operator in the chain is this take until. And what take until does is subscribe until the signal observable emits, and then unsubscribe. And so what we're saying here is, as long as this component isn't destroyed, go for it. Receive values, whatever. But as soon as onDestroy emits, close up shop. So another anti-pattern that I frequently see is the use of side effects in operators. For example, in this code example, we have an API service with a getData function that gets data for a URL. And we're calling Angular's HTTP client, getting this URL, piping it through a map function. But we're abusing the map operator to pull this .data out, right, to set a property on our API service. This has a lot of negative effects on an application's architecture. It introduces state in places where you probably shouldn't have it. It also introduces a race condition. If someone calls getData on 2 different URLs and subscribes simultaneously, we're not sure which one's going to end up getting set on API service in the end. So instead, it's a much better idea to keep your operators pure and to use stateless services wherever you can. And state management tools like NGRX can really help you with that. And the last pattern I'd like to talk about is a pretty cool one, writing a custom operator. An operator in Rx is just a function which transforms one observable to another. You can do that by either subscribing and handling all the mechanics yourself, or you can simply wrap other operators. And you can achieve some pretty powerful and readable code by taking up all the complex business logic that you have in transforming values and wrapping them into kind of your own DSL that you build up. So we're going to do a really contrived case. We're going to write an operator that counts the number of characters in every string that comes through an observable. So as I mentioned, an operator is a function that transforms one observable to another. And you can see that's the inner function that we're returning. It's very customary to write custom operators as a function that you call to get the operator, and that allows you to pass arguments into them. So if you look at how map and filter and concat map are all written, they take arguments in and then return a closure that transforms one observable to another. And using the operator is as simple as calling it from pipe, just like any other operator you use in Rx. So that's just about it. We've built a mental model of observables as